Welcome back. This is Raju Ketty. So today I will tell you how to carry out a milling process using a CAD simulation software. Okay. So before milling, we used to go through drilling cycles in drilling, normal drilling, drilling with counter boring, and peg drilling. I used to explain today. So in next class, we will discuss about milling operations, pocket and contour milling operations we used to discuss. Okay. So write a manual part programming for drilling cycle. So for turning, we used to discuss the coordinate in terms of x and z, whereas in case of milling, we used to come across a coordinate combination with respect to x, y, and z. X, y is with respect to billets and other things. Z is with respect to depth of cut. Okay. Similarly, in drilling cycle also, we used to come across a common syntax. First one is a program name, then the input. So SI or metric system input, G98 mm per revolution, G28 return to home position with respect to coordinate x0, y0 and z0. So tool change M06 T01 01 we used to take. I have made some mistake here. So T01 01 is the tool name. Next, spindle start with a speed of 1200. So absolute dimensioning G90, G00, X25, Y25 is the first coordinate with respect to this hole or with respect to this one, or it's a symmetrical hole pattern. So X25, Y25 will get a hole position into this one. Next, G99, once again the input parameters. Then G81 is drilling cycle. Depth of drill is Z minus 10. R is retract, come to reference point. Okay, once it's drill, it will come to reference of 15, feed rate of 50. So next we will use to give the coordinates with respect to this x25, y25 first coordinate, x25, y75 this one, sorry this one, x75, y75 this, x75, y25 this one. Okay, so x50, y50 is a center hole, G28, Z0, then M05 tool change. This is with respect to normal drilling cycle. Okay, so I will just copy this code and I'll tell you how the simulation will be. And your billet size is 100 by 100, thickness of 20. Then open your CNC milling cycle. We create a new part. Okay, so you have to write a program here, but I have copied the program which is already written. Then I have pasted it here. So same procedure, first is blank, iconic oriented or with respect to this one. So blank of 100 by 100, blank thickness 20, Z coordinate at the bottom minus 10. So whatever the thickness we used to give for the blank, you take the same thickness here. Only thing is negative sign has to be attached here. Then give OK. We used to get a blank here. Then machine type, Fanuc, select. Next, syntax, same procedure. Check your syntax. Next one is assign to. So here I have to take a drill. See, drill, insert drill or twist drill. So we have to take a twist drill here. Take a twist drill, diameter of 5 volts of dia 10. So I will take a drill of diameter 10. mm. Okay. I'll give OK here. Next is once again it's a line command simulation. This is a solid. If you take XY, only XY plane will appear here. If you take YZ, only YZ plane or XZ plane, or this one is isometric. So next and last option is simulation, give simulation. So drill tool will come here, initial position, to do the drilling, it will go to second. So it will finish its drilling cycle and tool will be returned to its home position. Okay, this is how drilling has been carried out. So if you want to look into this in a line mode, take an XY or YZ, then I'll give play. See here, we can see the depth of the holes. See, or else if you take XY, so you will get how the tool pattern is moving. Understood? So or else from this point itself, I can send it to home position. So for that, so reference it will come to that G28 Z0, X50 Y50, G28 it will go to home position with respect to Z0, M05, M30 tools. So this is for drilling. Okay. So next is next program is counter boring. Okay. So counter boring means first initially we have to drill a hole for a certain depth. After that, to place any head. Okay. For example, if you take up any nut and bolt, in bolts we used to have a head of hexagonal shape or square shape. So if you want to match that with respect to surface of the finishing, then we have to do the counter boring of the depth of our head thickness, whatever they will be, that much thickness will be drilled with respect to counter boring. So if you do that one, the head positions will be fit inside the material with respect to matching the surface of the work pieces. Okay, so we cannot get the projections of the head surface. So wherever it is required, we used to do that. Okay, so for this one, same procedure. So initial drilling, these 5 holes will be drilled. So syntax will be same. Program name. So initial positions. So we don't want G00 here. Okay, G21, G94 or G98. This one. G91, G28, X0, Y0, Z0, M06. So I have to do little bit modifications here. I'll do that one. Okay. So we used to perform this operation. The blank size is 100 by 100, thickness of 20, counter bore thickness of 5 mm, hole of 10 mm. Okay. So counter bore dia 15. Okay. And hole dia 10. So we carry out this operation. So I'll copy a program here. So same procedure, file, new. So save changes, yes. So I have previous itself I have told, first create your own folder. In that folder you have to save. So I have created my folder already in a desktop. Okay, I'll go to desktop, I'll take my folder. So untitled I give drilling. Okay, save. So I've taken a new file, I'll paste my program. But you have to write it here. So we don't want G00 here. G91 is not required here. G28, X0, Y0, Z0, M06. G90, G00, X25. Oh, sorry. I have to share this one. So I have taken this counter boring program. So I have just made a few changes here. Previously it was G21, G94 or G98 we used to take. G21, G98, G28, X0, Y0 or G94 both we can keep. M06, T01, 01, G90 is not required here. G00, X25, Y25 will comes to initial position. M03, G99 revolutions per minute. Okay, because we are doing drilling, we used to take G99 here. So G81 is peg drilling cycle. Z minus is not a simple drilling cycle. Z minus is the depth, retract point, feed rate. So these are the coordinates we have given. Next, M05 tool has been stopped here. G28, X91, X0, Y0, Z0. Home position we have sent. We have taken another tool, T0202. G90 X25. This is for boring. G82 is for boring. Z minus is the depth of that one. R retract point. Feed of 50. So we have given the same drilling command what we have given there. Next, this one is, so I have to write a program here. M05 G28 X0 Y0 Z0 M30. Okay. So I have written my program. Then same position, take a blank of 100, blank thickness 20. This coordinate, because I have to keep my tool with respect to this reference point. So if I given 20, from this point it will take 20. Okay. So negative 20 means it will comes up to this point. Okay. Reference point. This is 0 reference. Next, give OK. Keep it in isometric position. Machine, same. Fanuc. Next, syntax. Check your syntax. So number of lines check. Okay, I'll do that once again. So we'll take this program as it is, and I'll check once again. Not check the programs completely, that's why it's giving an error. So I'll run this once again. So I'll open my CNC mill. So create a new part. Maybe OK. Control B. So I used to write this here. G28 X0 Y0 Z0 M05 M30. Blank of 100 of 20 minus 20. Okay. So since it's a drilling cycle, the coordinate parameters will change. That's why we have taken this one. So I don't want G00 here. G21, G94, G91 is an input parameter. So G90 absolute, G00 rapid travel. Okay. So machine I'll take, Fanuc, syntax I'll check. So I have to assign two tools here. First one is a drilling tool. I'll take a drill, quiz drill of dia 10 mm. Okay. Second tool. Here for counter boring, we don't have separate tool called counter boring tools. Okay. For that we used to have end mills. Okay. So in that 3 float, 4 float, whichever we can select. So dia of this one is 15. Select OK. OK. Then give the simulation. So first drilling. So drilling cycle will be finished. So next one is counter bore. So instead of giving x0, y0, z0, if I give z0 here, check out what happens. So tool change P02. So if I given z0 here, it won't come to this position. Previously, if I given x0, y0, z0, tool came up to this point, then it went to z0. So from this point itself, I can give z0. So this is regarding drilling and boring cycle. And last one is peg drilling. And last one is peg drilling. And these are manual part programming for peg drilling. For peg drilling, instead of G81, 82, we are using G83. Remaining things will be as it is. So I'll copy a program here. So same thing. Go to file, take new. You know how to change the things. So I will take change same here. I'll paste my program here. Then I'll just simply do the remaining things. Blank 100 by 100. Thickness of 20. This also 20. Give OK. So next machine, select Fanuc OM type, then check the syntax. No errors and warnings. Since it's a peg drilling, I'll take only one tool. Simply, which drill we are going to take. So dia of 10. Peg drilling. Okay. So next, I'll give the simulation here. So I'll tell you what do you mean by peg drilling here. Just observe the simulation. I'll tell you what do you mean by peg drilling here. See here, just it will do the depth of cutoff 5 mm, then it will come to reference point. Okay, see, this is called peg. It used to go certain depth and it will come to reference point, then previous point to next further depth and it will come to reference point. That's why it is called peg drilling cycle. See here. So at 3 steps is doing a drilling here. So this will be done because of for longer depth holes, if you do the continuous drilling with the chips and other things, the tool may break. So the chips won't come out from the workpiece. If you do this peg drilling, with coolant pressure, the chips from the hole will come out and it will damage and it will not rupture the surface of the holes. Okay, you will get a fine finished holes here. So that's why it is called peg drilling cycle. This peg drilling cycle is generally used for long depth holes or more depth holes. Okay, so this is regarding drilling with counter boring and peg drilling cycle. Okay, so in the next class I'll tell you milling programs. Milling means pocket and contour, and another last option is thread cutting. Okay, so in next video I'll make those three programs and I'll execute using milling. Thank you.